Hello, this is Mr. Drach, and today we're going to be talking about molar mass, or also called molecular weight. Now, the mole might be something you've heard of before. It's not really a furry creature like you see over here. It's not the thing on Kate Upton's upper lip either. A mole is a completely different thing in chemistry. What a mole is, it can be a number of particles, which we see over on the left-hand side. It could be this many particles, 6 times 10 to the 23rd. By the way, that's why we're celebrating Mole Day on the 23rd of October, 1023. Okay, so it could be the number of particles. It also could be the volume of a gas at STP, standard temperature and pressure. So it could be a volume of 22.4 liters. But what we are looking at today is how many grams are in a mole. And for that, we're going to use formula mass or molar mass or molecular weight. Okay, so let's take a look at how this works. Now, the molar mass is just the mass of a mole of an element. And the mole is just an amount, kind of like a dozen or something like that. So we're trying to figure out how much a mole of something weighs. We could have a mole of an element, a compound, or even something else. And we're going to look at that in grams for our mass. Molar mass, sometimes you'll see it called formula weight, sometimes called molecular weight, and sometimes you'll see it as mm for molar mass shortened. Now, you might want to talk to your teacher about this, but most teachers agree that you want to round to about 1 decimal when you're looking for the molar mass. When you look at an element box like we see down here, okay, we've got the atomic number, we've got the symbol, we've got the atomic mass. And what you need to do to figure out how much a mole of something weighs is look at the atomic mass. Okay? If we look at the atomic mass, notice for neon, it's 20.18. And I tell my students to round that to 1 decimal. So 1 mole of neon is going to be equal to 20.2 grams. Okay, so I just rounded 1/8, rounded that up. If the number's 5 or bigger, we're going to round up. Lower than 5, and we'll round downwards. Okay, so we've got 1 decimal, and a mole of neon weighs 20.2 grams. That would weigh about $21 bills is how much that would weigh about. Now, different periodic tables kind of come in different formats. You can see I have 3 different ones up here. They all look a little different. The number you're looking for is usually a decimal. It's not always a decimal. It's always going to be the bigger number in the square. For example, Rutherfordium over here, notice the bigger number is 261, so a mole of Rutherfordium equals 261 grams. Okay, and that one we really didn't have to round because there is no decimal, and you'll see some elements like that. Now for iron, a little different periodic table here. We've got some pluses and minuses, some other numbers here, like some melting points and stuff like that. But again, the number you want to look at is over here. Okay, it's a bigger number of the 2 major ones. And again, we want to round that to 1 decimal. This one would round to 55.9. Again, that 5 rounds it up, grams. So a mole of iron would weigh 55.9 grams. For oxygen over on the right, again, the bigger number down here, we're going to round that. And that's going to round 1 decimal to 16.0 grams. Good to remember that oxygen is 16 because you're going to see oxygen quite a bit. So that's how we'd figure out how much 1 mole of any substance on the periodic table weighs. And again, every periodic table is a little different. You can use yours and kind of get used to how that works. Okay, there are some specific elements called diatomic elements. What diatomic elements mean is they always come in pairs. Di meaning 2, atomic meaning atom, so 2 atoms. Now when these atoms are alone, only when they're alone, not in compounds or anything like that, they don't really come by themselves, they come in pairs. Okay, the ones that are diatomic on the periodic table, if you look, are hydrogen, which is in the upper left-hand corner, and then nitrogen, oxygen, fluorine, and the rest of the halogens all the way down to iodine. Okay, and if you notice, it kind of makes a number 7 there. Okay, and there are 7 different diatomic elements. Okay, so that's one way to kind of remember it is by looking at the periodic table. It goes NOF and then down. They all come in pairs, and we write a little 2 after them, like chlorine. I'd write a little 2 after it because it's diatomic. Again, only when it's by itself. Another way to remember that is with the word Hofbrinkel. Hofbrinkel is just kind of a funny made-up word that in that word it's got all of the different diatomic elements: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Okay, so they come in pairs when they're diatomic. So if I got a question like, what is the mass of 1 mole of oxygen gas? Well, oxygen gas is by itself, so it is O2. Okay, and if I look at my periodic table, here's oxygen right over here. Okay, you notice that number. If I round that to 1 decimal, that becomes 16, right? But, there are 2 of them. So I'm going to have 16 and 16, because we have 1 for each. And that's going to weigh 32 grams. So 1 mole of oxygen gas is 32 grams. If I wanted chlorine, chlorine was by itself. It is again, one of those diatomic ones. So if I look at the periodic table for chlorine, right here, notice that one's going to round to 35.45. That's going to round to 35.5. Okay, so for chlorine, I would have 35.5 times 2, or add it twice, however you want to do that. And a mole of chlorine gas would weigh 71 grams. 71 grams. Okay? And again, that's going to be for any diatomic element, any of those ones that you see up there. Okay. And again, just to show you once more on the periodic table where those are: hydrogen, and then we go NOF downwards, and those are your diatomic elements. Okay. Now that's for all of our elements. All the other ones are going to be by themselves. They're just going to be one of them. Okay. Now, a little different when we have a compound. Okay. A compound, we have to add up all of the individual atoms. Okay. For example, I'm going to have whatever carbon is and whatever oxygen is, and we're going to add those 2 together, and that'll give us a mole of whatever carbon monoxide is. So let's look at carbon. Carbon is not one of those diatomic ones, and it's not by itself. So carbon, if I round that number right here to 1 decimal, it becomes 12.0. My oxygen, again, right over here, that one's going to round to 16.0. Okay? And I've only got one of them. It's not diatomic because it's not by itself. So I'm going to have 12.0, 16.0. Okay? And when I add those 2 up, I get 28 grams. So 1 mole of carbon monoxide is going to be 28 grams. So a compound works the exact same way. We just have to add up the individual elements. In our next example, it says, what is the mass of 1 mole of sodium hydroxide? So I have 3 different elements here. I've got Na, I've got O, I've got H. So we're going to go ahead and look those up. Let me just kind of erase a few marks here. Our Na, sodium. Sodium is over here. I notice that looks like that's going to round to 23. I've got my oxygen. Oxygen, we've already done this a couple times. Oxygen rounds to 16. And again, 1 decimal, 16.0, sorry, 23.0. And hydrogen. There's our hydrogen. Sorry, 1 second. Okay, we've got that fixed. And we also have hydrogen. Hydrogen would just round to 1.0. Okay, so I've got 23, 16, and 1. So when I add those up, my sodium 23.0, oxygen 16.0, hydrogen 1.0. We're just going to add all of those up. When we add all those up, we get 40 grams. I should say 40.0 grams. Okay, so when we add those up, 1 mole of sodium hydroxide would weigh 40 grams. Now those are pretty easy compounds to add up, and we're going to look at just a couple harder ones. For example, magnesium chloride. Here I've got 1 mg, so I'm going to have 1 mg, and I've got 2 chlorines. So now for my chlorines, whatever I've got, I'm going to multiply by 2 because I've got that little 2 right there. Okay, I'm going to multiply my mass by 2 because I've got 2 of them. So my magnesium is right here. that's 24.3. And my chlorine is 35.5. Okay? So, magnesium was 24.3 and chlorine was 35.5. When I multiply that by 2, I get 71, and this one is just 24.3. So when I add those up, I get 95.3 grams. That's how much 1 mole of magnesium chloride weighs. Okay. Now, a little different for calcium hydroxide. I have a couple different things going on. I've got calcium, and then I have OH. You can add those up individually, or you can add everything up inside the brackets and then multiply by 2, but either way you get the exact same answer. Calcium is over here. Whoops. It's right here. Okay, when I round that, calcium becomes 40.1. My oxygen is again 16. My hydrogen is just going to be 1. All right, so I'm going to add all those up. So my calcium was 40.1, my oxygen is 16, and my hydrogen is 1, so overall I have 17 inside the parentheses. I'm going to multiply that by 2, because I have 2 of them, to get 34 grams. When I add those up, I'm going to get 74.1 grams. And again, I'm adding up my 40.1 and my 34. Okay, so I'm adding up everything just like I did. The only difference is now I've got a parentheses and I'm just doubling however many grams I've got inside that parentheses. All right. Now lastly, we're going to be converting from moles to grams. Okay. To do that, let's say I have 5 moles of NaOH and the molar mass is 40 grams. We found that earlier. So what I would do here is start with 5 moles NaOH. And I know 1 mole is 40 grams. So I'm going to put my 1 mole on bottom and my 40.0 grams on top. And when I multiply that out, I get 5 times 40, and I'm going to get 200 grams. Okay? And I'm not using sig figs there. I probably should say 200 point grams, right? And then the second one says how many grams are in 2.5 moles of H2O. Hydrogen, if you remember, is 1 gram. I have 2 of those, so I've got 1 and another 1. And oxygen is 16 grams, if you remember that. So the molar mass of water is 18 grams. So I would start with my 2.5 moles of H2O. And 1 mole of my H2O is 18 grams. And then I would multiply that out. I'm going to have you guys do that on your calculator and tell me what you got. Okay. Now, the other way we can go is from grams to moles. Okay. It says how many moles are in 10 grams of NaOH. Exact same thing. I'm going to start with 10 grams of NaOH, and the only difference is this time I'm starting with grams instead of moles. So now I'm going to have grams on the bottom. Okay. The molar mass is 40.0 grams, and I have 1 mole. So now I'm going to be dividing by grams. So I have 1 over 4, and that's going to be 0.25 moles of my NaOH. So same thing, just a little bit different. We're flipping our conversion factor. Lastly, it says how many moles are in 600 grams of H2O. I'm going to have you guys do this one. Again, I'm going to start with my 600 grams. For my last slide, I know that 1 mole of water, H2O, is 18 grams. Okay, so see what you get there. But that's basically it for molar mass. That's Mr. Drach signing off. I will see you later.